So today we'll be talking about networking. Now, as cybersecurity personnel or cybersecurity enthusiasts, networking is actually very important. You can't do without having, even if it's basic knowledge about networking. So I just start. So networking. We say networking is the practice of connecting computers and other devices to share resources and information. Now, if you were in the last class, I told you something about network. That network is when you connect different computers, gadgets, or IoT of things together, you are creating a network. So now networking is the practice of connecting those computers and devices together. I told you we have IoT of things like camera, some refrigerators that mix use of the internet. Those are what we call IoT of things. So connecting all these things together, the process of connecting them together is what we know as networking. I would say it enables communication and data exchange using hardware. Example, routers, switches, and protocols. We have the TCP/IP, or you'll be explaining that later. Now, networking is foundational to internet and enterprise environment. That one is self-explanatory. So let's go to the next slide. So now we have network terminologies. Now, the first thing we have node. Now, any device connected to a network, e.g. computer or printer, is called a node. So any devices that is being connected to a network is called a node. For instance, now in your house is now, if you put on hotspot on your phone, if another device connects, now those devices are known as nodes because they are being connected to a net. So all the devices, including your own device, is known as node. Now we have host, a node that can send and receive data. Now host is a node or an end device that can send or receive data. Your phone can be an host once it's connected to a network. So far it can send and receive data, it is host. Now we have bandwidth, the data transfer capacity of a network. That is what the highest capacity of what can be transferred on a network in terms of gigabytes or megabytes. That's what we know as bandwidth. Then we have latency, delay before data transfer begins. That is, when there's a delay before transfer begins, is known as latency. Now we have packets, a unit of data sent over a network. Now, as cybersecurity personnel, you should be different from people that are not in tech. What they know as packets is, for instance, if you send messages on WhatsApp, you send message on WhatsApp, maybe you send hello to somebody. Now, there are actual, how will I put it? There are ways your message is actually being transferred to the other person. Now, the method of transferring or the information that is being transferred to that person that you are not seeing is known as packets. Now, there are devices that you can use to capture these packets, the way these informations are moving from one device to another. That is why WhatsApp will tell you that it is end-to-end encryption. What they are trying to say is that the packets that are being transferred are being encrypted. So if your hello leaves your phone, the process of it getting to the next person, when it's on transit, it is encrypted. That's what they mean by end-to-end encryption. So until it gets to the person before it decrypts. So even if an hacker or a cyber criminal should capture your packets, your WhatsApp packets, it is going to be encrypted. The person will not be able to see the exact message unless the person is very good with decryption, which is not an easy task. So you, on the other side, you sending the message, you have a pass key. Now, the person that you're sending the message to also has a pass key. So it's like you're locking it with your key and the person is opening it with his own key. If you go into your WhatsApp, probably on anybody's profile, just click on more profile. You will see where they tell you to check your security or your encrypted code or your passkey. It will tell you to compare to the other person. So that passkey is what is encrypting your data or your packets in transit. Hope you guys get me. Hope I'm not talking to myself. Can you guys understand what I'm saying? I can't see your.
Yes.
All right.
Yes.
All right.
Understand what I said.
So now we have types of network. We have the LAN, that is land area network. Connects devices in a small area like a building. So in your building now, if you have a router or you put on hotspot on your phone in your building, and the devices in your building are connected to that device, it is called a LAN, which is local area network. That is a LAN. Then we have WAN. This is wide area network. Covers large geographical areas such as countries. So in a country, you can have a WAN. In a community, you can have a WAN whereby devices or networks are being connected. Then we have MAN. This is metropolitan area network. Covers city-wide areas, larger than one LAN, but smaller than one. So it is larger than one LAN, but it is smaller than one. Then we have PAN, short range for personal devices like Bluetooth. So when you have a short range connection, that's what we call PAN. Then we have VPN, encrypted tunnel through a public network or secure communication. Now, VPN is just like saying, let's say you want to send message to someone. Now, you don't want the person to see your own information as the person sending it, because maybe we'll get there later. All network devices have something we call IP addresses. So now it is this IP address that you use to communicate over the internet. The IP address is like you're saying your house address. So if somebody wants to send a mail to you, the person has to know your house address, then the person sends it to your house. IP address is for devices. So the person has to know there's a way the computer knows your IP address, then sends the message to you. So now VPN is like tunneling your message through an encrypted tunnel, whereby your own IP address is not the IP address that is going to reflect that sends the message to the person. So it's as if you are tunneling your message through another place. That is what VPN is all about. So we have networking devices. We have router, forwards data packets between networks. So router is just like a device that is like gives internet connection or hotspots. A lot of you, we have pocket Wi-Fi. So all those things are examples of a router. Then we have switch, filters and forwards data to intended recipients in LAN. Now, what a switch does is that a switch is connected to end devices. Now, if from PC1 you send message to PC, you want to send message to PC2, it goes through the switch to send message to PC2. It's just like you are connecting a lot of devices to one device, a lot of endpoint devices to one device to be able to share messages. That is what a switch is all about. Now, hub broadcasts data to all ports, less secure. Now, hub is almost the same thing with switch, but the difference is that a hub, if you connect so many devices to a hub, if PC1 should send message, the message will go to all the devices on that hub, because it is not smart. The hub is not smart. It just broadcasts everything. Anything you tell is like this, it tells everybody. You understand? That is what hub. So that is why most companies make use of switch, because switch, if the message is not intended for that particular device that you're sending it to, it will not send it to any other device. But a hub, once a PC sends a message, it broadcasts the message to everybody. Everybody go hear what they happen. That is the difference between hub. So most companies, because you can see, they say it is less secure because it sends the messages. Once you send the message, it broadcasts it to everyone. Now we have a modem. Modem modulates and demodulates signals for internet access. Now, a modem is actually connected to the internet. We all know what a modem is. Most of us use it on our PCs. That's what a modem is. Now we have access points. Provides wireless access to a wired network. So access point is just like a device that helps to gain access to the network. It helps to authenticate those that want to gain access to a network. That is what an access point is. Now, please, are you guys following me? Are you guys following me?
Yes.
Yes.
All right, all right. So we have IP addressing and subnetting. Now, IP address is a unique identifier for devices on a network. We'll talk about the other thing following slide. We have static, subnetting. Okay, let me explain subnetting. Now, dividing networks to improve performance and security. Now, there's something we call subnetting. Probably I would demonstrate that. So subnetting is just like saying you are a particular IP address, you want to divide it into different subnets, in the sense that if you calculate your subnet, once you've calculated that subnet and you've given the subnet a particular calculation, now the particular IP addresses on that subnet automatically belong to a network. It's as if you have automatically segmented those networks, or you separated those networks. So it's when you depend on your calculation, it will have range. So from this IP address to this IP address, this particular network, from this IP address to this IP address, this particular network. So it depends on your calculation. Then we have CIDR notation, e.g. /24 defines the subnet mask. So it's almost the same thing as subnetting. Now this defines the subnet mask. So I would show you what I mean by that. Let me just explain. Okay. So now IP address. IP address, also known as Internet Protocol Address, is a unique identifier for a device on a network. It allows devices to communicate across local networks and the internet. So two main versions. We have IPv4. We have the IPv4 example. We have 192.168.1.1, which is a 32-bit. It supports 4.3 billion addresses. So in the world now, the IPv4 address we have is 4.3 billion address. Then that is why they had to introduce the IPv6. So the IPv6 has not fully taken over. We are still making use of IPv4, but most devices now come with both IPv4 and IPv6 address. So the IPv6 is almost about on decillion because it has larger bits. Imagine 128 bits. So it will be hard for us to go to exhaust the IPv6 addresses. Now we have types of IP addresses. We have the public IP. Now these are assigned by internet service providers or for internet access. Now we have a public IP. Now the public IP is usually assigned by your internet service provider, just like in Nigeria now, MTN, Glo. So if you are using MTN to browse, MTN automatically assigns you a public IP. Now we have private IP used within local networks. Now all devices, let me see. Okay, all devices have an IP, a private IP address. We have both static IP address and dynamic. Now, dynamic is an example of the public address that your network provider issues you anytime you want to go to the internet. It can change anytime. Then we have the static IP address. That one is the one your device is assigned. It does not change. So every device has their own IP addresses. Now, to make you understand this, if you put on hotspot on your phone, now if you connect to, maybe about 3 people connect to your device, now your device automatically assigns those other devices IP addresses. Now the IP addresses it assigns them is known as private IPs. Now everybody is communicating because it is now your own device, which is your own hotspot, that will be using its own public IP address to communicate to the internet. So all those devices connected to your internet are communicating with your own public IP address because you are like the host. You are the one with the hotspot. You are like the host. So they communicate with your own public IP. I don't know if you guys are getting me. So all those devices, your device issues them a private IP for them to communicate within the network. Now they will now be using your own. So if they are messaging somebody outside the network, it is your own public IP that they are using to communicate over the internet. So let me quickly see if I can show you what I mean by what I was explaining before. So we have IP address, let's say 192.168.1.1. This is an example of an IP address. So the calculation of IP address is usually done in binary. Calculation of IP address is usually done in binary numbers. So for the binary number calculation, we'll be making use of what we call the BCD numbers. Can you guys see my screen? Well, are the letters bold enough, or should I enlarge it?
It's good,
Yeah?
you can see.
You can see, okay. So we have the BCD
Letter-
numbers. So we have 128, 64, 32, 16, 8, 4, 2, 1. Now this part is actually going to be interactive so that I can be sure that everybody understands. So now if we want to turn our IP address into binary, we have 192. We have 192. Now we will look for, from these BCD numbers, we look for numbers that when we add them together, we actually give us 192. So you can also try it on your side. From these BCD numbers, you look for numbers that when you add together, it will give you 192 from this BCD number. So let's say we have 128 plus, let's say 32 plus 16 plus 8 plus 4 plus 2. Sorry, 128 plus 64. The 128 plus 64 gives us 192. So that will now be everyone that you got the number from, everyone you got the number from will be represented by 1. So we got our number from here, we got our number from here, so the rest will be 0. So that means for this IP address, we have 1100000. I think that's 6 zeros. So that is our 192. So the next one, .168. If you are not getting it, let me understand so that I can recap, or you wait for a question session so you don't forget the question you want to ask. So somebody should try this 168 and let's know the numbers you will have together. So that I will just be the one doing it. So now, what's each numbers that are being separated by full stop has 8 bits. That is why they are represented by 8 bits, zeros and ones. You know binary, zeros and ones. So for this one, let's see what do we have here. We have 128. That's 128 plus 32 plus 8. Okay. So we have 128. And mind you, you cannot repeat numbers. You cannot repeat numbers. So don't think you repeat. So we have, to get 168, we have 128 plus 32. Right? Plus 8. So the rest will be 0, 0, 0. So that means our 168 gives us 1, 0, 1, 0, 1, 0, 0, 0. That is what our 168 gives us. So we have 1 will give us 0, 1. Yeah, do you have it? Do you have any question?
No, I'm just looking. Sorry, I'm just joining from here because I went to hacking pen test class. So they just finished some.
You people that are going from one class to another. Even one class enough for.
I thought we are going to finish this one before going to that one. So when I now saw that class, I thought it's the same class because
Not the
we
same
had
class.
agreement that we're having this one today and that one will be next week.
Not the
So
same class.
I don't know
It's
if it's a different class.
But normally, if you're in cybersecurity, introduction to cybersecurity, you're not supposed to join any of that track. If you think you can multitask, because this track alone, even the best person in cybersecurity is still learning. Yeah, so that's it. So this is what we have here.
So this BCD number is standard the way it is.
Yeah, this is how you calculate. Yeah, so we have 128,
28, 54, 32, 16, 8.
That's how you calculate.
Okay. So I'm trying to get binary.
Yeah, something like that. So now you guys must have seen something like this. 255.255.255.0. Let me show you something. So if you want to check your IP address on window, not Kali, use IP config. Yeah, use IP config. So it shows you. So this
internet adapter
shows you. Yeah, this internet adapter shows you your IP. So this is the IPv4 address. This is my IPv4 address, and this is the subnet mask. Now we'll show you what the subnet mask. So you see that everything is on the same subnet mask. This one is on the same subnet mask. So on the same subnet mask. Now the subnet mask is the one that decides what all the networks are on. It's one that decides what all the networks are on. So you can use the subnet mask to subnet your network. So this subnetting now, this 255.255.255, it means it's on a CIDR or CIDR, like I showed before, of /24. We told you how we got that. Okay. So now .0. So if we use the same method for this, you discover that you get one, you can try it, you get 111, which is 8 ones, 1, 2, 3, 4, 5, 6, 7, 8. So you get one. So now this is 8 bits. Now, if you count this, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 will give us what?
24.
24. So that's how they got the /24. So that means this particular IP address is on a network of 192.168.1.1/24. That is what this means. So this is the CIDR notation. Now, how do they get the networks here? Can somebody help me do 2 raised to power? Wait, is it 2? Wait, though. Let me make sure I'm not making a mistake. Help me do 2 raised to power 8. Let me do 2 raised to the power 8.
256.
256, right? So 2
Yeah.
raised to the power 8. 2 raised to the power 8 equal to 256. Now, what this means is that if we have a slash 24, now you calculate the remaining zeros. Now you raise it to power 2. You know the remaining zeros we have as 8, you raise it to power 2. It means that on a network, we can have 254 devices. On a network, we can have 254 devices. Why is it 254? Because when you have a network, you must leave out 2 networks. One is your network address. Let me type in it. One is your network address. Your network address, which is going to be 192.168.1.0. Don't forget we're using this this IP address. This is what we are using. So 192.168.1.0. That's going to be our network address. .1.0/24 to show that it is on a subnet mask. So they call this a subnet mask. So to show that it is on a subnet mask of 255.255. That is what this /24 means. So we'll leave out our network address. We also leave out what is that one called? We also leave out a broadcast address. Now the broadcast address is going to be the last address on the network. So that's going to be 192.168.1.255. So now this is going to be the last network on that address, which means if you have, or that means, let me make it clear to you. That means we are having, the addresses we'll be having is 192.168.1.1, 192.168.1.2. That's 1.3 till we get to .1.254. So now if you count now 1 to 254, those are the devices that can be on that network. Are you getting me? Are you guys following? So those are devices that can be on that network. So the reason why they make use of 244 of these 255.255.0 is because you can have 254 devices on a network. So it is large enough to admit those on a particular network. So if you have that network, that is 254 devices, right? Then you want to move forward. Now, what happens is you cannot have 256. What now happens is your 256 is as if you are carrying one to the back. So you now have the next network address will now be 192.168.2. Now listen, this .2 that you are seeing here is almost as if you have jumped 254 times. I don't know if you're understanding what I'm saying. So you cannot have 256. It will now carry one to the back. So you now have 2.2.1 all the way to 192.168.2.254. This is another network, another 254 devices. Now, this is like the calculation of segmenting. So if this IP address, let's put this one now, 192. dot 168.2.2. So the network address, can anybody guess what the network address for this one will be? What will be the network address for this network range? So we have 192.168.2.0/24, because the /24 is this 255.255, which is what we use to do the subnetting calculation. So on all the devices, when you are configuring it, this 255.255 will be there to show that you have a subnet mask of /24, which gives you a total of 254 devices per network. So before that network will be full, you need 254 devices to be connected to that network. Are you guys getting me?
Yes. Yes, we're getting.
So inside this, let me not forget also, inside this
Sorry, keep one.
oh yeah, okay.
Excuse me.
Yeah, I can hear you. Hello, can speak? See that? Who was talking just now?
Listen.
Person has stopped talking. Even if this is what we do today, at least we'll make sure that everybody understands. We'll still try another subnet calculation for you to see what we are doing. So, okay. So what I'm saying is it will not be 254 devices, sorry, it will be true. So now what I'm saying is it is not going to be 254 devices, because you need to leave out one IP also, which is known as your broadcast IP. Now, this broadcast IP, most times network engineers always decide to use the first IP on the network, or you can decide to use any IP address. Now, this is your broadcast IP. Now, if you look at this place, you notice that there is no, they did not even put the broadcast here. Okay. When we start working on Cisco Packet Tracer, you see, okay, sorry, yeah, a gateway. So you see that the gateway is not here. This is a gateway now. So now this default gateway that they put on this IP address, it is going to be on all, this particular gateway is going to be on all devices on that network. Let me tell you what I mean. Now, what should we use as our gateway? Let's use the first network on the device. So the first IP network on the device is .1.1. So this is going to be our gateway. So this is going to be our gateway. So why do you need a gateway? Now, this gateway, so all the devices on this network, now we have to configure these gateways on all these devices. So the device of 192.168.1.2 must have this gateway. If you are doing manual configuration, everything must have this particular gateway, because if any PC on this network wants to communicate with any PC on this network, they use their gateways to communicate. So now this one, we have its own gateway also. So let's use the first network on the device also. So this one, so when you are configuring, you configure the gateways to communicate, for them to be able to communicate amongst each other. If not, if you don't configure the gateway, if anybody on any system on this network sends a message to any system on this network, it will not go through if the gateway is not configured. Are you guys getting me?
Yeah.
So now let's try. Okay, what do you say?
But
Let me
what
hear you.
about if it is dynamic?
Now, a dynamic IP address. Now, the thing is, most times when companies configure their network, they make it manual configuration. So most manual configuration are static IP addresses. And again, companies don't really make use of dynamic IP addresses because it is not good for business. Because an IP address that has been assigned to them is like their own business IP already. So if you are changing your IP addresses, it's not actually advisable. It is normal and personal devices, you can be changing an IP address, having dynamic, but most companies have static IP addresses. Does that answer your question?
All right.
So now for this one now, we are having 253 devices on a network. So let's say our segmenting or our subnetting, we want to reduce our subnetting to less devices on a network. Cipher base. Okay, my boss.
Yeah. Well done, Mr. Anthony.
Yes, sir.
Yes, sir. Well done.
Yeah.
Yes. Sorry. Based on the person that asked question about the dynamic IP address system.
Okay.
So, yeah. Of course, you have already explained everything, but I just want the person to know that that dynamic IP addresses is just that, just like Mr. Anthony said, we have 254 IP addresses that is available to be assigned to different devices, which he also said that one of the IP is used for brokers, which is very, very correct. Sure, you understand. So, but dynamic IP addresses is that, let's for example, in SYC organization, I normally use popular organization that we understand, which is Google or Tesla, all those popular organizations. So let's assume that we have 254 employee there. Sure, you understand. So
Yeah.
that IP will be assigning. You can leave it as static, just like he said, or you can use dynamic. Dynamic will be assigning random IP to every users. And immediately you disconnect from that network, it will assign the IP to available person. Sure, you understand? Or it will reserve it for the next person to join. Sure, you understand?
Yes.
But just like he said, it's not stable. So that's why when you're as a pen tester, I don't know, maybe you're in the group of hackers and all that stuff. As a pen tester, you have to, if you want to do something like that, a static IP is very, very advisable. Very, very advisable because it makes your network very stable compared to dynamic one.
Okay.
So that's just about that. Thank you very much. Mr. Anthony, you can continue.
All right. Thank you, sir.
Yeah.
So now let's assume we want to reduce our devices per network. We don't want it to be just this general 254.254. So let's say we add this to this. Or let's say we add 3. We add 3. So that means it will be, please help me add this. 128 plus 64 plus 32. So that will give us 224.
224.
So this will be, so this will be 224. This will be 224. So 224. So now we have, 8 times 3 is 24 plus 3, that is what? That is 27, right? So this network now, or should I just leave this one and start it afresh? Let me just, how should we do it? Should I edit these ones?
No, you can edit.
Should I edit these ones or I should do it on another page?
Do it on another page.
Let's see. Like this. So this one is 24. Let me do it like this. Yeah, but you should see when you get the recording, you'll be able to see it. So let's say now this is 27. So our network, our address now, our CDR now is changing to 27, which means it will also reduce the numbers on the network. So I say you should do, so how many zeros do we have here now? We should have 5. So 2 raised to power 5 should give us what? 2 raised to power 5.
32.
32. So now instead of having 253 devices on our network, now we'll be having 30 devices on each network. So this is our subnet mask. This network address will now be 20/27. Then our broadcast address will be the last address on the IP, which is going to be .31. So we have .1.0 as our first IP. Then we have .31 as our gateway. So the next IP will be starting from network address 192.168.1.32. So the next address will be starting from 32. So what you just do is it will be starting from 30. So what you just do is 0 plus what we raise to power is 32, right? So that's giving us 32. So our broadcast address, which is going to be the last address on the network, so our broadcast will be 192.168.1.31 plus 32. That will give us 63, right?
Yes.
So that's 63. That will be our broadcast address. So the ranges on this network will be, the range will now be 192.168.1.1, 192.168.1.2, .1.3, all the way to .1.30. Are you getting me? All the way to .1.30, because we have our broadcast address already, which is 31. Then our address is starting from .1. So now what this means is, okay, let's do the next one. So the next one will be .1 /27. 27. .1. So it will not be .2, it will still be .1. This .1. .1.32. No, 33 will be the first IP address on the network. Then we have .1.34 all the way to .1.62. No, sorry. See how .1.35. So all the way to .1.62. So now if we keep going, what did I say this one will be? This, okay, our gateway, right? So our gateway is the first address on the network. So .1. Now your gateway, you can decide to use any of the network addresses in that network, but you just make sure that when you are configuring your system, all the systems on that network must have that gateway. If not, we have issues. So the best thing to always remember is most times people just use the first network address, so that they will know that when they are starting their configuration, the first device is going to start from 34. So the first device is going to start from 34, 35, like that. Then the first IP will now be your gateway, because that is what you're using to communicate between networks. So now if we continue like this now, so that means we'll keep having 32 devices on each network. So now if any device on this network wants to communicate with this device, we have to make use of the gateways. Let me just, do we still have time? 24. Let me just show you what I mean by this. Let's just do something. network packet tracer. So you can understand what I mean by that. So the reason that they usually make use of that 255.255.0 because it can take about 253 devices. So there's no need to stress themselves. But if you want to reduce the number of networks in a particular group, you can always do that. So okay, when you open your, I said I will teach you how to download. Time. Let me just try and see. So when you access the link that was sent to you, you go to download packet tracer. Now I'm using 64 bits for Windows. So you click on download. Now, because I already have this, now once you download, you install. Now, when you install, if you want to open it, most times it usually prompts you to open a Cisco account. So just open the account. After opening the account, it will open the Cisco packet tracer for you, just as simple as that. So when it opens it, then you can have this. Now, let me just do a simple explanation of this. So yeah, you have your devices. These are your network devices. These are switches. These are routers, sorry. These are routers. Then down here, you can have your switches. This is a switch. You just carry and drag. This is a switch. Then these are endpoint devices. If you need a PC, you need a laptop, you need a server, like that, you can drag. You can drag there. Then these are your cables. So these are the cables. So under here, you have different options. You have different options here. That's simple. So up here, this one is just to unclick. If you want to, like this thing I clicked now, if I want to unclick now, you click on this one, it will remove it. That is what this is for. Then with time, you get to understand the rest. But the one you really need is this simulation. Now, this real time means anything you are doing is being done in real time, just the way it is when you do your connection in real world. Then simulation, if you want to make use of simulation, that means you want to be looking at it as the thing is going. You don't want it to be in real time. That is what you use simulation. So let's quickly design a simple network. So let me use a switch. Let me use a router. Okay. Well, this thing go long. See our time. Let me use a router. So we have a switch. We have a switch. There's another switch here. My endpoint devices. So I have a laptop, I have a PC here. I have a laptop, I have a PC here. So now I'll use my cable. Make use of this cable to connect this. Let me use fast internet 1. Connect it to this place. Let's use Giga 1. I carry this one, you connect here. Fast internet, connect to this one. That's Giga 2. Do the same thing here. Connect to this one. 3. Something more. Connect to that one. This. I'll connect this fast internet one. If we do router configuration, let me just connect this. So now on this PC now, let me configure. So you go to desktop. You go to IP configuration. Now, yeah, let's set our IP address for this device. So let me see the IP address we're going to make use of. So let's make use of this one. So you have 255.255, that's our subnet. So first IP 168.1.3. Okay, let's just do that. Okay, so let's our network IP address. So let's give this one 192 based on our calculations. So let's give you 192.168.1.3. So our subnet mask is 255, but because we are using a network of /27 CIDR, so that means we have 224 here, right? Am I correct?
Yeah.
Yeah. So our gateway, we said we want to make use of the first IP on the network. So we have 192.168.1.1, right?
Yes.
Okay. So that's set. Let's check. Yeah, so that's set. You see, automatically it gave it /27. Can you see it here? Automatically it gave it /27. That's to show you that our subnet mask is /27. So let's label this. Okay, let's label it. No. Let's label
Hello,
this.
sir.
So yeah, can you hear me?
Yes, I can hear you. Please, I have a question. Will the recording of this class, will the recording be dropped on the
Sure,
group?
sure. The recording will be dropped.
Okay, thank you,
As you
sir.
can see, the recording is ongoing. So
Yes, well, ask in the chat.
yeah. All right. What's this thing? Let's see. Okay, so let's say our network address. Our network, this network is on 192.168.1.0/27, right? So that's what this our network is, this network. So this one, we are using the second. This one, we're using the second one. Let's say 192.168.1.33/27. So that's 1.32/27. That is network. So that's what this network is. So for this one, let's give this one, we go to desktop, IP configuration. So we've given the first one .3, right? So let's give this one 192.168.1. Let's jump a little bit. Let's go to 25 because 25 is still with the range of our 1 to 30. So this is 224, sorry. Then our gateway 192.168.1.1. You realize that on this laptop, I also gave it this same gateway, right? So on your device on that network, you have to give it that gateway. So we have that configured. So this one now, this is under network now. So let us do this. So we have 192.168.1.35. So the 1.35, our subnet mask 224. Then our gateway. So our gateway is 192.168.1.33. I think that's the first IP on that network. So yeah, that's 1.33. So the IP network address is supposed to be 32. First IP is 33. Okay. So that one is done. Let's give this one, go to desktop, IP config 192.168.1. Let's jump a little, let's go to 50. I think 50 is still with the range. Let's go to 50. So this now. So 355.224. Default gateway 192.168.1.33. So now let us try something. Let me enter this network now. What is this IP address? This is 192. Where's the IP address? Okay, 192.168.1.25. So let's try to get a request from this PC. So we use the command ping. So if we use ping, we have 192.168.1.25. Yeah, let's try to ping it now. Okay, sorry, because we're on simulation mode, so I have to go and press play. Let's use real time. Let's use real time. Can you see it as it was able to ping that device? This is the request I got. It shows that all the packets I sent about 4 packets and I received 4. None of the packets were lost, right? Yes. Now let's try to ping a device on this network. Let's say. Now let us ping ahead. Now let me show you what a broadcast address does. We said our broadcast address is going to be 192.168.1.31. So let's ping our broadcast address. So ping 192.31, right? So now if I ping this, now what happens is that if there are 10 devices on this network, it will ping all the devices for me, because that is the last, your broadcast address is the last address or last IP address on that network. So because it is only pinging PC .2.25, because it cannot ping this one again, because that's the device we used to ping it. But if there were other devices, okay, let's just add one other device to this one. So let's add a laptop to this so that you understand what I'm saying. So we use our cable to connect. Let's connect. Let's connect one. So now let's do this one. Let's give it IP address of 192.168.1. Let's say 29. So subnet max .244. 244, sorry. Default gateway, I think is 192.168.1.1. All right. So now let me try and ping. Let us ping the broadcast again. Now you can see, if you can see clearly, now you see that it's ping 25, it's also ping 29. Can you see, can you guys see it? Can you guys see it?
Yes, yes.
So you see it's ping
Plus
25. So that is how it is going to ping all the devices on that network. If they are, here now on this device now, on this particular device, we can have 30 PCs on this device. So now this is segmentation. This is segmentation. I'm already teaching you guys, right? This is segmentation. So we are segmenting with switches. I guess in this is a switch. This is another switch. So we are segmenting with switches. Now there's also an advanced level of segmentation. If your company, because now if you have, let's say in a company now, you have about 10 departments. That means the company has to buy 10 switches if they want to segment. But if the company does not have money to buy switch, you can do segmentation on a switch. It has its configuration, but it's an advanced level. It's not what we can start doing now. So if the company doesn't have money to buy enough switches to segment, you can segment on a particular switch. Now we can have as much as different segmented networks that we want on just one switch, whereby it's not interfere with each other. So now let me try and ping. We tried to ping. Let me ping this network now. So we have 192.168.1.35. So let's ping it from this place now. So ping 192.1.35. Okay, let's ping. You can see it is not going through.
Yes.
You can see it is not going through. Let's now say, okay, let us put it on this same switch. Maybe you are feeling because it's on another switch. If we put it on this same switch, let me say, let's add another device. Let's add another device to this place. So let's say, yeah, this connected to this. So now let's give this one. Let's give this 192.168.1.37. Subnet max 255.224. Default gateway 192.168.1.1. So let's see if it's going to ping it, even if they are on the same switch. So what did I give it? .37, right? I gave it .37. You know .37 is on another network by our IP calculation. So let's see if it will ping it, even the fact that they are on the same switch. So can you see it's not seeing that PC, even the fact that we put them on the same switch. That means that we segmented already with our calculation. So that means it has to be within the range of that 32 devices, of that 32 IP, before it can see that device. So now this device now, it is not seeing this device because it's not on the same IP range as what we configured. If it were to be on the same IP range, it will be able to ping each other. Do you understand that part?
Yes.
Yeah. So now for us to be able to ping this, what do they call it? For us to be able to connect to this network, we now have to do our configuration on our router. That's when they will now communicate with the broadcast, sorry, with the gateway address. You now see where gateway is coming in. So I have to now configure this router that lets this switch gateway be able to communicate with this switch gateway, which automatically we assign a gateway to this network, we assign a gateway to this network. So that particular gateway is what I will now configure on this router to make them able to communicate. You guys understand? So that is segmentation. Let me see if we'll be able to do the configuration before I'm sorry for keeping you guys till this time. Let me see if we'll be able to do this. If we can't do it, we'll move it to the next class. So now what we'll do is we'll go into our router. Go into our router, we go into the command line. Now you press enter. Sorry, no, for this one. So the first thing, enter. So the first thing you do, you say enable, then config T. So now we want to access this interface. This interface that is connected to the router, you can see it's gig 0/1. That is what we want to. So now we enter there. So we say interface G0/1, right?
Yeah.
G0/1. So we want to work on this interface. So we have. So now we're inside that interface. So we have IP address. So we have IP address. Now the IP address we will now put is the gateway of this network. So we have IP address 192.168.1.1, right? That's our gateway, right?
Yes.
Then we'll now put our subnet mask, which is 255.255.255.22. Is it 224, 224, right?
224, yes.
We click enter. Then we now use the command no shutdown. That is to make our router operate no shutdown. So now if you notice it, you see that it's already green, which means it has connected, right? Right?
Yes.
Can you guys see me?
Yes,
so now,
yes.
we've connected this interface. Now we need to go and connect this other interface. Now to connect this other interface, we need to enter this interface here. This is G0/0, right?
Yes.
So we need to enter that interface too. So first we exit from here. We exit again. So let's start from beginning. So when we started from beginning, we used enable. Right? Then we use config T. Then we use config T. Then we use interface. We want to enter interface G0/0, right?
Yes.
So we use the IP address 192.168.1.33, right? That's our gateway that we set there. Then our subnet 255.255.255.224. Enter. So we say no shuts down. Enter. So now let it.
It's also connected.
It's also connected, right?
Yes.
So it's still connecting. So let it finish connecting. Now we'll now try and ping again to see if it will go to the other network. Let it finish connecting. It's still orange here. It's showing that it's connecting. Now this is the real life scenario. This is how it happens in the real life scenario. So now this configuration using switch to segment is actually very simple. But if you want to segment on a switch, that you want to segment different networks on just one switch, it is another thing entirely, because you have to start naming different VLANs. You come to this switch, you name the VLAN. Maybe you want to have 3 departments of this on this place. You have, let's say you have VLAN 10, VLAN 20, VLAN 30, that's 3 departments. Now on those 3 departments, you want to have 30 devices each on those 3 departments on just this same switch. So first you name VLAN 10, 20, 30 on this switch. You come here, you name VLAN 10, 20, 30 on this switch. Now you will not connect directly to a router, you connect to another switch. Now that switch will be serving as what we call trunking. So that's an advanced class. Let me not put you guys on.
But in all these connections, will there be any latency?
No, there's no latency for now. There's no latency for now. So let's try and ping which network should we ping now? Okay, this is 192.168.1.50. So let's try pinging that. I see the 168.1.50. Let's try. Can you see it's pinged now? Yes. Before it wasn't pinging. That is because we configured our gateway. So we are now saying, Mr. Router, please, we want you to use our gateway to communicate from this network to this network. So this is what they call segmentation. So imagine an hacker gets into this network. It will be easier to quickly disconnect this other network from the router so that the hacker will not be able to hop into this other network. Once an hacker gets into this network, it is only this network that will be compromised. That is the essence of segmentation in network security or in cybersecurity as a whole. So that is what they mean by what? Segmentation. So if an hacker gets here, he will not be able to get here if this one is disconnected. But an hacker can still enter this one because there's something we call VLAN hopping, where an hacker can still hop from this network to this network if it is not disconnected on time. Do you understand me?
Yes.
So yes. That is where we'll be stopping today. Sorry.